For today's agenda, we have this presentation, the opening and welcome, that is going to be about 5 to 10 minutes. And then we have the NOUS project goals and methodology at 10:10, when we will explore the objectives and methodology of the NOUS project. This segment will offer a comprehensive overview of our goals and the strategies being employed to attain them. The NOUS project is focused on developing a European cloud service architecture that facilitates the use of multiplex computational and data storage resources. Further details will be provided in the section of this agenda. So, from of expertise, we have at 10:30 with Diego Valdeomillos presenting distributed ledger technologies. This session will delve into the innovations and application of blockchain. Blockchain technology provides a transparent, secure, and decentralized method for managing data and transactions. Diego will explain how distributed ledger technology works. After that, when Diego finishes, Geray Mezquita will present Federated Learning and Natural Language Processing at 11 o'clock. This talk explores the fusion of Federated Learning and Natural Language Processing in the context of customer service chatbots. The presentation begins with an overview of Federated Learning, highlighting each decentralized approach to training machine learning models while preserving data privacy. Subsequently, it delves into natural language processing techniques used within a chatbot framework for understanding and generating coherent response to user queries. An illustrative example is provided, detailing how Federated Learning facilitates collaborative learning across user device while safeguarding sensitive information. These innovative combinations ensure both data security and model refinement, culminating in an efficient and privacy-preserving customer service solution. So, after a short break of 10 minutes at 11:30, we will have our next presentation about the key results, outcomes from our previous NOUS workshop. This recap will help us to build on our past achievement and set the stage for the future progress. After visualizing the results of our previous workshop, where we gained valuable insights and feedback that have influenced our strategies and caused us to change some of our project approach. In this session, we will delve into the most significant results of the previous workshop and explained what key points were obtained and the main way forward for our project. During the time frame of 12 to 12:30, there will be an engagement in a mural collaborative activity. This interactive session has been structured to cultivate teamwork and facilitates the exchange of ideas among all participants. Mural offers a digital workspace for visual collaboration, enabling us to engage in real-time brainstorming, planning, and execution ideas. The primary objective of this activity is to harness the collective intelligence of the group, thereby fostering creative solutions and promoting collaborative problem solving. Finally, we will conclude with a discussion and question answer session scheduled from 12:30 to 12:50. This session provides an opportunity for all participants to ask, offer feedback, and engage in a constructive dialogue regarding the project. At the end of the session, our colleague from FCS will explain to us the NOUS Community Hub, which is currently active on the website. We believe it is important to join this initiative because it is a space where stakeholders come together to connect, collaborate, and contribute to the advancement of the cloud service in Europe. So this is the agenda from today's workshop. Thank you for your presence today. Your participation and insights are essential to the success of the NOUS project. We anticipate a productive and inspiring workshop and hope that you will find the session informative and engaging. Your attention and integral role in this journey are greatly appreciated. So let's move to the next presentation, the NOS project goals and methodology. So the NOS project aims to develop a European cloud service architecture that enables the utilization of computational and data storage resource from edge device, supercomputers, HPC network, and quantum computers, serving as an infrastructure as a service and platform as a service cloud provider. NOS integrates edge computing and decentralized paradigms to enhance Europe's data processing capabilities. The proposed objective is under the overchanging goals of digital transformation and European sovereignty. We intend to stabilize a robust and integrate cloud service architecture to deliver a scalable and secure platform capable of supporting a wide range of applications, from scientific research to industrial automation. So our main focus is to develop the development of a technical framework to link Europe's HPC network with quantum computing. This integration is designed to increase computational capabilities and support a wide range of applications. Quantum computing represents a significant advancement in processing power, allowing us to solve problems that are currently beyond the capabilities of classical computing. By linking HPC network with quantum computing, NOUS aims to establish a hybrid environment where both types of resource can be seamlessly utilized. This will not only improve computational capabilities, but also drive innovations in fields such as cryptography, material science, and complex system simulation. So we are also working on a data processing and standardization initiative. This involves creating a module to integrate data from both physical and digital sources, optimizing edge-to-cloud computation and standardization data and formats in case sectors using data lakes. Data standardization is important for ensuring interoperability and efficient data exchange across different platforms and applications. By developing standardization data processing modules, NOUS aims to simplify the integration and analysis of data, making it easier for organizations to use big data for decision making. The use of data lake will provide a centralized repository for storing and managing large volumes of structured and unstructured data, which will facilitate advancement analytics and machine learning application. So NOUS is developing a European cloud service suite architecture. This suite includes computational, edge computing, and data processing component aimed at enhancing EU digital sovereignty. The architecture aims to provide seamless integration and efficient utilization of resource. The digital sovereignty is a main priority for the EU, ensuring that Europe has control over its digital infrastructure and data. The NOUS architecture is designed to support this goal by providing a secure, scalable, and flexible cloud service that meets the needs of diverse stakeholders. By integrating edge computing, we can bring processing closer to the source of data generation, reducing latency and improving performance for real-time application. Another critical aspect of NOUS is the establishment of a platform inspired by Living Labs for exchanging knowledge and sharing data. This platform enables collaboration across different domains, allowing various stakeholders to interact share insights, and develop innovative solutions together. Living labs are a space where users and developers can work together to design and test new technologies and services. By embracing this approach, NOUS aims to cultivate an environment of open innovation and co-creation, bringing stakeholders from diverse sectors together to address common challenges. This platform will facilitate a wide array of collaborative activities, such as an innovation workshop. So to achieve our goals, NOUS is forming a strategic partnership with several initiatives, as you can see in the slide, to enhance the data interoperability. Our aim is to enable data sharing and establish a cohesive European cloud service framework. Collaborating is key to success of the NOS project. By partnering with initiatives such as Gaia X, Fireware, and EOS, backed by a consortium of 21 partners from 11 European countries. This partnership will help us to leverage existing. Okay, can you hear me?
Yes, we
Yes,
can.
perfectly.
Okay,
Yes.
just turn on the headset. So this partnership will help us to leverage existing standards and technologies, ensuring that our solutions are compatible
Yes.
with other major initiatives and platforms. So as we say, the NOS architecture consists of computational, communication, and data storage components. So an open source approach ensures that our solutions are transparent, flexible, and adaptable to different needs. By providing open access to our components, so some of our components, we enable other organizations to build on our work, fostering a broader ecosystem of innovation and collaboration. So our methodology includes several key components. The first one, requirements, elicitation, and best practice. We start by gathering requirements and best practice from previous work. We have previous work and a lot of partners working with some project that can help us with this stage. So the next one is the layers. The first one, compute. This involves connecting the HPC network, utilizing Zenlens Quantum HPC integration, and ensuring robust cybersecurity. The second layer, the edge layer, we focus on federated learning, parallel programming, and load balancing. And the last one, the data layer, includes blockchain integration, data standardization, and the connection with data space to and the connection with the data space to provide all the data that we need from this project. So the SCS architecture serves as a backbone integration, legal research, data economy, and living labs for data sharing. That's all the components from our methodology that, as I said, is so necessary to work, for example, with the living labs for data sharing with the stakeholder and all the person involved in this project. So this methodology is crucial as it ensures that we cover all necessary aspects to develop a robust and efficient cloud service architecture. By following a structured and systematic approach, we can ensure that our solution meets the needs of our stakeholder and deliver tangible benefits. So I talk about our partners. The NOS project is supported by a consortium of 21 partners from 11 European countries. Our partners include universities, research institutions, and companies from various sectors. This diverse collaboration ensures a comprehensive approach to tackling the project challenge. Our consortium brings together a wealth of expertise and experience from across Europe. Each partner plays a crucial role in the project, contributing their unique skills and knowledge to help us achieve our goals. This collaborative approach ensures that we can address the complex challenge of developing a European cloud service architecture from multiple perspectives. So I think that that's all about the project, about a, a little of information about NOUS project and our partner. So we have our website, when I encourage everyone to visit our project website at the link that appears in the slide, nousproject.eu. The website provides extensive information about our objectives, partners, methodology, and progress update. This website is a valuable resource for anyone interested in the NOUS project. It offers up-to-date information on our activities, publication, and events, as well as opportunities to get involved and collaborative with us. Also, we have profiles in Twitter and LinkedIn if you want to following us, that all the person involved in FCS provides to us, and also with the website. So I have to say thank you to them, to Elena and Sofia. And once again, thank you for being here. Your participation and insights are crucial to the success of the NOUS project. So after this, we have the next part of this workshop, where Diego Valdomillos will present distributed ledger technologies. Sorry, I don't know if. Let me check. Okay, Diego is
Yes,
here.
I'm
So
here.
Diego, where are you one?
Hello, how are you?
Fine,
Let
fine.
me share if I can start if you want.
Okay, I think that. Okay.
Thank you. Are you watching my screen?
Yes.
Perfectly.
Okay, thank you.
Yes.
Well, like Alberto introduced before, I will talk about distributed ledger technologies. I will do a brief presentation about this technology. Maybe someone don't know it, so I don't want to start talking about how to integrate data space and blockchain and distributed ledger technologies without explaining a little bit what is blockchain. And next, we will review some use cases in data space with related with blockchain and with and some projects that actually they are using or used in the past blockchain with data space. So, well, what is this of distributed ledger technology? It's a series of technologies that acting like a decentralized database that are peer-to-peer networks. There is some data replicated in multiple networks, and this technology allows to have a secure and transparent ledger to record all the transactions and all the operation that happens in the network. The main key features of this technology is the decentralization, because there are not a single entity, central entity to discuss about the transactions. There is all the operation are done using algorithms and cryptography, and they require a peer-to-peer network. Also, this technology allows to have all these records in a transparent way. All these transactions, you can access to the transaction history, transaction logs, and so on. And also, this gives truth to the rest of the users, to the rest of the peer-to-peer nodes. And also this technology is immutable. This means that once the data is recorded, you cannot change it. This is important, this last point, because for example, if you are thinking in have some personal data in blockchain, so you are maybe doing something illegal. So you need to check what you want to record in a blockchain, a distributed ledger technology or not. So in DLT, there are two main technologies that everybody talk about. This is one is blockchain and the other is directed acyclic graphs. I will explain a little bit about this. Blockchain, I'm pretty sure everybody knows here about Bitcoin. I'm sure that someone of you maybe lose money with this, others maybe earn some money, and others maybe knows because some gains or some other news in the what is this blockchain? Like I mentioned before, both of technologies, also the acyclic graph and blockchain, are peer-to-peer network. This means that all the data is replicated in the participants in the rest of the nodes. So a blockchain is a chain of blocks that have a structure like are you watching in the slide? This has the structure of this of a block. It has the transactions, all the transaction record in the block. Also, we have some algorithms to help the nodes to work with this. This is the Merkle root. And also all the blocks has a timestamp because all the data is tamper-proof in the blockchain, and we have the hash of the block and the hash of the before block. This means that with these hashes, you can link one block to the before block. So here we can see all the structure, more or less. There is a lot of implementation. This is just a typical one. Also, I mentioned about the nouns. The nouns, for example, is used in some blockchains to allow the consensus algorithm to resolve the problem, to resolve the puzzle, to get the consensus. So with this number, they are trying to play with him using brute force to, for example, in Bitcoin, to change this number to get one hash with a number of zeros in the case of Bitcoin. So for that, for this technology, we are using cryptographic algorithms like hash and elliptic curves. One of them is the hash is a simple mathematical function. If you have an input, you have a different output. So, but it's only in one way. And the other important algorithms in this technology is the elliptic curve. There is a lot of elliptic curves in different algorithms and blockchain and so on. But with this, for example, you with the public key and private key, you can have a wallet, and with your private key, you can sync the transaction. So this is the cryptographic that allows blockchain to work in a secure way. So also, I think it's interesting for the project to talk about the types of blockchains, because if we want to use DLT in the project, well, if you use some public blockchain, you need some coins of this blockchain. You need to have some hardware. So there is problems like scalability, security, and so on. So there is a lot of implementations about this with multiple consensus algorithms, with different type of blockchains. The typical idea of this is in European project, it have these blockchains in a private or consortium network. So one of the most important technologies in this kind of this in these blockchains is a Hyperledger Besu. This technology is based on Ethereum. It also is compatible with the public network, but it allows you to have different consensus algorithms that allows you to have a consortium blockchain. For example, maybe you hear about ERC. ERC is the European blockchain that has for example, a framework for self-sovereign identity that now is used in some data space. They have all this record in a system with the NOUS, the peer-to-peer network is deployed in partners about the European Union. So maybe it's interesting use some technologies like this for develop. Hyperledger Besu, for example, is pretty simple to configure to have into a developed environment, and also use with Etsy because it's the same technology that implements European blockchain. And for that, we need smart contracts with the first it was Bitcoin. It only allows to have transactions for money, but then Ethereum appears. With Ethereum appears a lot of application, a lot of standardization about how to work with code in blockchain. The idea here is you can code some application and transaction will be like methods that you write in the blockchain, and you will store some data, and you will recover some data from blockchain. Sometimes it will execute automatically, depends on the conditions. So for all the use cases that can maybe are important for work with data space, we will need a smart contracts. With a smart contract, we can, for example, create tokens or money for the data. You can also have some money that allows you to interact with technology like an euro, for example, like the representation of euro, but in a tokenized way. You can have this data tokenized. You can have traceability systems, a sovereign identity. You can have decentralized finances, or for example, decentralized autonomous organizations that allows you to operate a data space with an autonomous way, with some clauses and so on. Also, there is the other technology that is important, but is less used because not more people knows about it, is the directed acyclic graphs. It's just another representation of how to solve the data secure and distributed manner to put this data. It's like a blockchain, but with other structure. For example, here we have some examples of the iota tangle and the hash graph algorithm. So I will not give more details, just if you want to know that there is other technologies, there are more fast in mean of transactions, for example, but they are more complicated to work with them. And also, some of them there is no compatible with the Ethereum virtual machine that allows you to deploy smart contracts. So now I will introduce some use cases about DLT in data space. The first of all is self-sovereign identity. This is described in a lot of technologies. For example, if you search about the Eclipse minimal viable data space, you will find some information about this. If you watch the FC, the European blockchain page, they have all this in a way that all the data is for all the members of the European Union. If you search some information about international data space, they also mention this way to identify a person or entities. There is not the only way to do this, to have this, to identify this organization and person. For example, you can use some certificates like X509, but this is one that you can use with blockchain. So for that, we have three important elements. The first one is the DID, or the W3C distributed identifiers. They uniquely represent any person or entity, and in data space, the DIDs represents the participation organizations in the system. So a DIDs alone acts like an anonymous pseudonym, so a trusted authority links it to the real identity behind it. This link is stabilized through public key and private keys. Again, elliptic curve cryptography by associating this DID with a public private key. For example, in the image, the DID method specific identifier should be in, for example, in SC is the public key of the wallet, and the sample in the DID is in FC is the name of the technology. So DID FC and then the public key of the wallet. And possession of the private key proves that the organization owns to the DID. The next one is the W3C verifiable credentials that represents verifiable identity attributes that belongs to the DID, to the person, or to the organization. These verifiable credentials are issued to the organization behind the DID by a trusted authority, and it allows an offline verification of the credential. And the last one is the verifiable presentation. W3C again is a standard that allows the verifiable credential to be transformed to show only the necessary information to another user or another entity or organization. For that, some cryptographic protocols enable creating this presentation without the intervention of the central identity authority. So this is why it's decentralized. Now we will check how to use this in an onboarding process, for example, for a data space. The onboarding process for an end user with self-sovereign identity and a participant can be divided into two parts, obtaining the attested DID, first one, and the next is register identity attributes. In the first one, the end user generates a new private and public key, a wallet pair, and stores the private key in a secure way for him. The user then creates a DID with this public key, they use it like a unique identifier string, and link this DID also links to the participant real identity. The user requests the identity authority to attest their DID that the identity authority verifies that the user is the real entity, and the identity authority attests the DID by singing it digitally. So the user registers their DID in the distributed ledger, making the DID discoverable for all the participants. The next phase is after obtaining a valid DID for the central authority, that the user registers the attributes with one or more identity authorities. And this could be different from the authority that attested this. This is allows to you to have some other organization or other external authorities in the data space. For example, if you want to have some if the DID is attested by EPSI, for example, for a central authority in a country, in Spain, for example, but you can have the option to attest the information with the authority of the data space. So the next one is this slide is after obtaining the valid DID and it's trusted. The user can request a verifiable credential from one or more identity authorities in the data space that can attest some identity attributes needed by the user, and the identity authority retrieves the DID from the blockchain to confirm the user identity. The entity authority finds the identity attributes associated with the DID and creates the verifiable credential for these attributes. And the identity authority provides the verifiable credential to the user and record the proof of this issuance in the distributed ledger. The user then transforms this verifiable credential in the verifiable presentation that reveals that only information needed by the data provider and so on. The next most use case in data space is traceability. Here is an example on how a smart contract can work with this. The idea of this is have all the information in a data space, all the steps that you, for example, you register data or publish metadata, or you transfer data from one entity to another entity, from a data owner, data provider to data consumer. All these steps should be registered in blockchain, but you also need to have some considerations about, for example, public data or so on. But you can use some cryptography like hashes or something like this to have this data like a secured way in a public distributed ledger. The other system that is used in data space is have some smart contracts for the access policies for the data. If you have, you can define all the rules and the usage rules and the policies. If you allow to access your data and so on, you can use it with a smart contract. The next one is the oracles. They are not very useful in data space, but it is related to the project. But so we will need to find some use cases for this. The idea of the oracles is like a bridge in between the external from internet or external data the blockchain. But how can you do it if you don't want to have some dependency of external source that maybe is a point of failure? So you can use some consensus and some operation also with a lot of cryptography and so on, having a Oracle network that allow you to have some consensus about the data. Just imagine read data from a sensor, temperature data, and you have several information. So you need to have some consensus about what is the real temperature. And once this is used, the Oracle, you can put this data in a secure way in the blockchain. Also, oracles are used for integrate with other systems in blockchain. Imagine if you want to use some artificial intelligence, but you cannot do it in blockchain. You can use this system to operate some data outside blockchain and put it again in the system. And now I will review some of the projects using data space. The first one is a marble. There is used for traceability. It's data transaction recorded. It creates a record. Is for storing it also used for verification on the integrity of the data. It allows to, this is Amable is for 3D printers. It's a space for 3D printers. So for example, if you have some file, it allows you to have these hashes of the files in the blockchain, so you can verify the integration of the file, and also used for user control and privacy. The next one is boost for 2.0 is for it uses the blockchain for traceability for all the transaction in a supply chain. Market 4.0 is more or less the same. Is for, as you see in all the cases, traceability is like the main point of the system. So again, for data integrity, traceability, and integrity and verification of the data, and also it allows to have facilitates negotiation and security storage of legal contracts between parties. To have some policies about the data. And the next one is Isar that use a figure system that previously they have an hyperledger fabric that allows all the participating registry and acts like a trust anchor. So it was for identity verification, contract signis, policies, technical standard. All uses this system called Satellite for the data interaction. And now they are also using, Figuar is using Canis Major, that it provides a very full and immutable log of transactions. Again, traceability. Based on NSGSILD JSON format that is for smart data, and they put this data like a JSON in a tokenized way using non-fungible tokens, and also it allows to have other kind of transactions. This component of the Figware ecosystem allows you to connect with different systems and different blockchains. That's all. Thank you. If you have any question.
So thank you so much, Diego. It was a really interesting talk. So now it's time. So, and if you have any question about that, I think that the talk is really inspiring our project in the topic of blockchain and also in the distributed ledger technologies. So I don't know if someone of the Work Package 5 where blockchain works in knows have any question. If not, we can move to the next presentation with Jerai. So Jerai, I don't know if you are here. Okay,
Oh,
yes,
good morning, everyone.
you're there. Okay,
Okay, can you hear me?
morning. Yes.
Alberto. Okay, let me share the screen. I need to. Okay, can you see it?
Yes, perfectly.
Oh, great. Let me hide this. Okay. Okay, thank you very much for the introduction, Alberto. I'm Jerry Mezquita. I'm working as a senior researcher in Visite. And well, today the talk I'm going to present to you is going to be for some kind of not new but hot topics. Like in this case, we are going to focus in federated learning and natural language processing and in the use of chatbots that could help the NOUS project. Well, nothing. I think I don't need anything else for the introduction. So let's move on. I have prepared a roadmap for this talk, so you can follow it. In this case, I'm going to start with a little bit of an introduction to chatbots and why they are important in the current context of the industry. Then I'm going to follow by introducing federated learning. What is federated learning? What are the principles that it works under it? And a little bit of a comparison between federated learning versus traditional machine learning. Then I will introduce natural language processing, NLP. In this sense, I'm going to talk about the components of that are being used in NP. Also, kind of a revolutionizing idea, the one that not idea, but it is a technology, transformers. It was the revolution in technology behind ChatGPT and all the improvements in natural language processing that has been done in the past 3-4 years. So yeah, I'm going to talk just a little bit about it. If I wanted, I could stay all the morning, all the evening, and try to explain them. But just a little bit of an introduction here because I won't have time for this. And then just a little bit of an example of implementation about chatbots, what they can do, and how they can be used in a federated learning environment. Also, I'm going to end this this proposal by providing some insights about it, not only the good part, but also the bad part, the things that we don't like to talk about usually. So yeah, and then there's a little bit of a conclusion for this talk. So first of all, what it is. What are chatbots? Okay, chatbots are a kind of artificial intelligence that are being used in order to help customers have 24 hours, 24/7 service support, and also relieving the companies with the increased expenses of hiring more people that have to be for most of the time sat in a chair, looking at an empty screen, because usually they don't have enough talks, enough customers to connect, to ask, or the opposite. They have too many customers that they cannot respond to anyone, to all of them. So in that sense, the customers are going to be left. Some customers are going to be left behind with a bad. Will put a bad reputation to the company, to the service, and also the opposite. Perhaps the the employees are going to have a bad time. They are going to be bored because there are not enough work to do, and they are going just thinking that their time is going to be wasted. Their time, their talent, and so on. The opposite is also true, because they could be over how to say the word, overheated at work, and of course that will cause them problems. So yeah, it is important. This service, this machine learning started as a way to smooth this process and improve these services that are being given to the users, to the clients. Okay. So yeah, it helps not only with the support, it provides personalized interactions, because usually customers provide some of their data once they start interacting with the bot, etc. So in order, based on that data, on those data, the chatbot can personalize the answers, and they can provide a more focused service to the experience to the user. Okay. Also streamlining the processing, the streamlining the process, because of the as I told you, they automated the process, and the service is going to be smooth for the clients. They won't have those waiting times that avoid them to that are tedious. I mean, we don't want to wait in a line just to ask a question that can be answered in 10 seconds. Okay, so yeah, it's a good way to provide a better experience for the users, for the workers, and of course for the company, because they can spend less resources in a human way. Okay. So yeah, this is the good part of the increasing of the use of chatbots. But as always in this life, there is a black and there is a white. Okay, so yeah, the increasing of the chatbots, it's increasing public concerns about the data, how it is managing, how it is stored our data, what it is done with our data. Okay. It is really a privacy concern, because yeah, we can provide sensitive information even if we don't know about it. For example, some things like Alexa or Siri, they can store our data in their databases. With those data, usually it is possible that those data is stored even if we don't ask the chatbot in explicit way. Okay, so it is important to be aware of what it is happening with the centralization of our data, with the data we're providing these companies, and what these chatbots can do with those data. So first of all, we are going to try to provide some insights about the technologies I presented in the introduction, that those technologies will help that are trying to help in this kind of concerns. First of all, we will talk about what is federated learning. And federated learning is just a way of using machine learning in a decentralized way. Okay, it is just a way. It is just an approach in which machine learning can be used without the need of a central authority that will store all the data that it is produced by the customers, and it is going to be used to train the models. Okay, because of this, because of the lack of this need, the data are going to be kept inside the local devices that it is going to be produced. It is going to be that it is being produced. Okay, so for example, there is a clear example of data of a federated learning approach in which all of us, we have a phone. Okay, we have an iPhone, an Android phone. It is the same as smartphone, in which we are going to use a keyboard. Okay, the keyboard we are used to see some kind of help when we are writing. We write a word, we write a sentence, and then the keyboard usually predicts what will be the next word. In this sense, you are going to say, if you haven't asked yourself how it is done with your data, in which it is trained with the way you usually write. It is trained in the way you speak, in the information you write in the keyboard. So it could be a real problem if this data is shared with everybody, or at least a central authority has stored this data, because we don't know what they can do with this data. So in this sense, federated learning is being used in order for people that use these keyboards, the data that it is recorded, that it is logged by the keyboard, it is going to be kept local, while the training process is going to be it is going to be done locally, but also it is going to be improved with other local processes in other smartphones. But then the thing is, they are not going to know what data are they using in order to train the model. So yeah, keep this as a starting concept. Okay, I'm going to explain the process in a more deep way in order for you to understand it better. But now keep it like that. We have smartphones. The training is done. The training is done in our smartphone. That means that the data, it is going to be stored locally, and we are not going to share our data, our passwords, our way to speak to other people. Okay, so that is important. That is important because we are protecting sensitive information with this process. Okay. And also, it is important to note that it is going to be more efficient than traditional methods. For example, if we are a big company and we want to do to create a model, a machine learning model that needs a lot of parameters, that it is going to need a lot of data in order to train it, we're going to need somewhat powerful devices, powerful servers, powerful computers that will improve, that will carry out this process. Okay, that will run this process, that will run this training, that will create the model. On the contrary, the opposite, we are having those our local models, our federated learning model, or decentralized approach, in which each device, it's a part of the training process, is going to be done in a distributed way across different clients, partners, or whatever it is our use case. In the case of the model, the keyboard, the Gmail keyboard, for example, the Google keyboard, it is going to it is not going to use the computational resources in order to train the model. I mean, we are going to use it somewhat. I'm going to explain it later, but they are not taking part actively of it. They are letting the users, the customers, to improve their own model in order to provide a better service. Okay, this is the concept I want you to interiorize. So, what are the principles of federated learning and how it is being used? Okay, in this case, we have to be aware that this process is done in rounds. Okay, we are going to have the devices, okay, the local devices, the distributed devices, but we are also going to need a federated servers. Okay, the central server. This server doesn't train the local model, the models, okay? But it is the central part for this for the coordination of the process. Just coordination for now, okay? How it is done? Okay, the process starts by the nodes, the local each distributed device. It is going to be registered with the server saying, hey, we are going to take part in the federated learning process. Okay, we are going to be customers. We are going to be a part of the platform. Okay, so the federated server has an initial model, a model initiated with unknown parameters or a previous trained model. Okay, at this point we don't care. It's just we have an initial model, and this model is going to be sent to those devices that are going to take part in the federated learning process. Well, okay, so the server sent it as the blue arrow. Okay, sent the initial parameters. In this case, what we call initial parameters is the model weights. There's going to the model weights. You imagine a neural network, an artificial neural network, and it is what it is. It's weight. It is the transition part between each of the neurons. Okay, and that it is what we are sending, what the federated server, the central server, is sending to the distributed nodes. In this case, then once the distributed nodes have each one received has received a copy of the model weights, what they do is use their data, the local data, to train again over this model, iterate over it, okay, to make a process of training in this case over this model. So once they have done individually, they will send it again to the server. The server is going to wait. It is going to wait until all the round is finished. All the nodes have finished their training process. This is the number 3 step, okay, the proper one. And then in this case, the federated server, it is going to aggregate the model. The aggregation part it is usually done by averaging the weights. Okay, there are some other ways to do it. Some ways that need to be researched and to implement or to try at least in some use cases. But usually, in a general way, what it does is do an average of the weights. Okay. Now you have to you're seeing that what we are sharing information, but what we are sharing is only the weights of the model. Okay, usually it is more complex than that. Okay, you can share. You have to share a proof of the data you are trained your model, because some attackers could abuse this could exploit this process by training their model with data that it is rubbish or just noise type. So it is important that we share some kind of fingerprint of the data we have used in order to let the server know that we are good participants and that we are not attackers. Okay, then it has its own ways. We are not going to introduce that because I mean I don't have enough time. I am not going to be able to explain this well to you if I need it. So then, once this average, this aggregation, This is the aggregation step. This aggregation is done in the server. The server broadcasts the new aggregated model to the local nodes, to the distributed nodes. So then the nodes can use or train again if it is another iteration process of the training. It is another iteration of the training process. But then they will have the updated model from all the data that has been used across the devices. So with this, we have been able to achieve two things. First, distribute the process, improve, providing allowing the central company to have less computational resources in order to train. They just need to make aggregations and be aware of the coordination of the process. That's it. And then also we have been able to avoid the share of private data, sensitive data that could be problematic for us users. Okay, so yeah, it is interesting to know this kind of approach, the potential of this approach, and so we can just share some different, just to compare what it is federated learning to traditional machine learning. Okay, we can say that, for example, one of the key differences is the data allocation, in which in federated learning, the devices are the ones that kept their own data, the data that are being used, and then the traditional central training, we use a central server in which we give them our data and we make it responsible of the data of our own data, our private data. So in my opinion, even though there are a lot of regulations like now, no one assures us that our data cannot be breached, cannot be attacked by malicious, by some attackers, hackers that can rob our data, steal our data from the central server. So it's better if we are the ones that are responsible for our data and have it allocated in our devices. Also, privacy risk, because of this, is low in federated learning, while in the traditional centralized training, it is high. It is really high, not only because of the company that could sell our data, but because of the attackers that could focus their intentions, their attacks, to a company that they know it will have a lot of data that they can use to get money from. Also, the data transfer is minimal, okay, just the weights and some fingerprints of the data that we have used, while in traditional centralized learning, we have large amounts of data that are being shared, okay, continually shared. Also, the training efficiency, it is more efficiency to have a distributed network of devices in which the efficiency is higher than in which a centralized server is used for this training, because also another problem here is the bottlenecks that could be carried out, or perhaps if a server has a problem, the bigger computer has a problem, then their availability will be lost. While in federated learning, if a device doesn't have an internet connection or doesn't work in this training, it is okay. We will have another 5 devices that could do the training process. So once we are finished introducing what a federated learning can do, we're going to talk a little bit about NLP, okay? Natural language processing. What is it? What it is? It is a kind of machine learning, okay? It's kind of artificial intelligence that we use in order to interpret and generate human language. In this sense, we are providing the computers to the ability to understand us and interact with us in a way that we can understand also them. Yeah. Okay. So how does this work? this work by we provide them with queries. We ask them usually we ask them something. For example, what time is it? You use ChatGPT. What it is going to be? Can you traduce this? How can you help me traducing this this part of this text? For example, we are providing to the computer with queries that it will transform, and then it will interpret, and then it will transform again in order for us to interpret those queries again. Also, it is going to generate natural language responses, and the most important part right now, and I think the most advanced in machine learning that it has been done in the past 2 years, we have been able to engage in meaningful conversations with the AI. It is not perfect right now, but once you have tried ChatGPT 4 or Gemini 1.5, 1.5, you will see you're seeing the power, the potential that this technology has in this sense right now. So how is this done? This is done by first tokenization. Okay, we put input test, the user's input, our test. It is going to be tokenized. Okay, it is going to be split into words, and then it is going to be transformed. Okay, it is a lot of speech taken, but it is needed as part of the process in which it is le matas the text. It is also it cleans the text also, okay, and it transforms the words into vectors. This is a really important part, because usually what we do is represent with numbers in order for the computer to understand each word. It is important to pick which numbers are going to represent each word, because it is in our interest to know those words that are closer to each other, closer in meaning, I mean. Okay, perhaps those verbs are going to be closer than a verb and a noun, for example, but a name and a verb, that a noun and a verb that are usually related to each other, like the dog barks, they are going to be closer also. So it is important to know the representation of this in a vectorial space. Okay, it is going to be a vectorial space of different dimensions, usually a lot of dimensions. So okay, we will have a question, but I will answer later. Okay, so we're going to have like this. We need to be like that. Okay, we have to represent each word in that sense, in that way. So then, okay, it is using the entity classifier and then semantic analysis in order to generate then the natural response. After this, it appeared the transformers. Okay, it was a neural network that its focus, its main point was using attention. Okay, the paper that provided this, that created that implemented this approach, the first paper, that the one that it was by Google, and its name was Attention is All You Need. Okay, it is just a kind of neural network. This neural network, what it does is a way in order to provide each word with a token, not a token, but a vector of numbers that it is called attention, self-attention. Okay, in that sense, you are knowing, each word knows to which words are previous or usually previous. Okay, which and itself, which what meaning it has or how close it is to the other words, in order to know which what words are related to. Okay, it's like when we say the dog barks, we know that the barks is related to the dog, and dog is related to the. Okay, it is a way, if you want to. I mean, I cannot explain this very deep, but But it is important to know that this is the key concept that allowed us to communicate with computers like we are doing like right now with ChatGPT, for example. Thanks to that, it is possible to keep attention, to allow the machine to keep the attention of a large amount of large text. Right now they are increasing the number of parameters, the tokens that we are passing it, and it is able to keep the attention on them. Okay, that's a good way because it's like us. If we have a lot of attention, we are going to be able to remember what we have been talking about since the first of the conversation. Right now, for us, it is normal. It is normal that you don't know what was my third or fourth word in this presentation. It's normal. We don't have that much of attention. A machine, yeah, this sense a computer can have, because right now there are models that have billions of tokens. Billions, I think in the US way, not in the European way, right? Okay, but either way, there are a lot of tokens. I don't think I have spoken that much in this whole presentation. So you can imagine the power of this if you're able to keep the attention on each of the tokens, to keep the context of everything. So in that sense, we can summarize knowing what NLP can do, what it is done, and we can extrapolate in a use case of what a chatbot can do. In this sense, just what we want is just to answer customer questions about products and service. So we don't need a great number of tokens in order to provide enough attention, and resolve customer issues and provide customer support. Okay, we don't need to keep a large conversation. We don't need to have that big of attention. So well, that's something we have to take in mind. So how does how it could work in chatbots and further learning? In this sense, we can have in each of the in our device, like in the way of Google Keyboard works with our smartphones, we can have in each of smartphone or on each of the device or on each of computer in which our customer is accessing to, we are going to have a chatbot. We are going to have a chatbot that it is going to be trained locally. The information we are sending to the chatbot, we are talking, it is not going to be sent to the central server, but it will train in almost a real time. In almost real time, it's in its device, okay, in its node, the centralized node. So then, yeah, with that, we are going to be able to then send what our conversation, the model of our conversation with our chatbot to the centralized server, so you can aggregate with other customers, with the other models of other customers, in order to improve the resource, okay, the model. So with this, what we have learned, what we have needed, or we have learned about this, we have learned about the privacy preservation. We have learned that we can reduce the risk of breaches, of data breaches, and the efficiency of the training. But there is a big problem, and it comes with the natural language processing, and usually they are really big, as I told you. There are a lot of tokens that it is needed, a lot of tokens, a lot of parameters in order to keep a lot of attention, okay, to keep a big context. Also, we have the problem that usually our devices are not they are not high computers or supercomputers that can create a really difficult process or a really complex process of training. So yeah, you have to take that into account. So how can we solve this or try to approach this by reducing the number of parameters, reducing the attention? So as I told you, usually a chatbot don't need a great big deal of parameters, but we can reduce it. It is a problem because perhaps the conversation it is not going to be that fluid. That it is you said that it happens in ChatGPT, for example. So you have to seek a balance between the precision of our model, the complexity it can handle, and the possibility to allow the users to use the chatbot in a restrained environment. So yeah, as a conclusions, we have talked about what it is filter learning, what it is natural language processing, how a chatbot works, and how it is preserved the privacy of the users, and how can we approach it.
Hello everyone. I'm Enrique Mesonero, and I'm going to explain the key results for our previous workshop, the workshop of the milestone 4. The conclusions from the last workshop, which were complete from the mural and divided into various topics, addresses several key areas. First of all, in the domain of the high performance computing, the discussions highlighted the importance of optimizing the high performance computing task scheduling to enhance the efficiency and performance of computational tasks. Additionally, there was a focus on effective data management within HPC clusters to handle large datasets efficiently. The workshop also emphasized the need for improved HPC cloud networking and communication interfaces to ensure seamless integration and data transfer between HPC systems and cloud infrastructure. Secondly, for quantum computing, the participants explored methods of data encoding to facilitate quantum processing. They discussed the development of quantum algorithms designed to handle data stored in the cloud, aiming to leverage the unique capabilities of quantum computing for cloud data analysis. Another critical point was the creation of a robust APC and quantum computer software interface to enable smooth integration between these high performance computing and quantum computing systems. The Euro High Performance Computing initiative was identified as a valuable test bed for experimenting with and validating these new technologies and methodologies. In the field of federated learning, the workshop emphasized the development of privacy-preserving methodologies to ensure the confidentiality of data in personalized health research. The use of federated learning was also proposed for analyzing data related to materials and device failures, which is crucial for predictive maintenance efforts. In the part of natural language processing, the conclusions included the creation of a chatbot navigator designed for non-experienced high-performance computer users. This chatbot aims to provide a smooth integration experience for users new to NOUS resources, guiding them through the basics of resource shapes and highlighting the benefits. Additionally, an interface was proposed to direct users to NOUS resources that meet their specific requirements, including access to the appropriate computational codes and software packages. The workshop also recommended developing a chat interface to offer tailored advice for navigating domain-specific challenges, such as locating relevant datasets and recommending the most effective models for training. Regarding the decentralized computing, the participants discussed the development of decentralized algorithms for data sharing and aggregation, including AI models. They also emphasized the need for decentralized algorithms for resource management in the computer continuum. Frameworks like Apache Hadoop were considered for their potential in supporting decentralized and distributed computing. In terms of efficient exploitation of continuum resources, the workshop highlighted the use of fast flow-like approaches to efficiently exploit edge computer resources. Other technologies that some of the partners mentioned in this workshop included using Ellipse Research Labs as GitLab as the repository for project code to facilitate open collaboration, and the consideration of development operation technologies like Assemble on Jenkins was also encouraged to streamline development and deployment processes. There are the different focuses or the different conclusions that we had in the previous workshop. We aim to all of the participants of this one to perform or to contribute with their experience or their different knowledge in different areas. For example, the areas mentioned here: high performance computing, quantum computer, federated learning, etc. So for this task, we are gonna start with a collaborative mural, as we work in the previous workshop. So Carolina, if you want to present.
Yeah, now we are going to create an interactive mural, as Enrique said. So please go into this link that I'm sending you. And add all your knowledge about those topics. Also, as Enrique said, there is a column for others, so you can add other topics that you think that could be interesting. And as you can see, the topics are HPC, quantum computing, federated learning, NPL, decentralized computing, efficient exploitation of quantum resources, and other. So please write in these sticky notes, and if they aren't enough, I will make more of them. And finally, on the right side of the mural, you can give us feedback about the workshop and write questions about what you have covered today and what you like about it and what you didn't like. Even though we are going to send you, well, Sophia is going to send you a feedback form at the end. So we are going to be happy for you to give us your feedback. So now I can see that people is in the mural.
Yes, I'll think before start with mural. Please, all of the participants that can't edit because they are not members of the mural, please send by chat or emails for give you the possibility of edit in the mural for your proposals.
Yeah, the sticky notes, I mean, here you can see the blue ones and the purple ones. There you can just, I'm not sure if you're seeing mine, but you can here just write hi. Are you seeing it? In federated learning that I have just write that. So please, if some of you know things and think that is in, it could be useful for the project, just write it there.
Hello, everyone. I think you can hear me, right?
Yes.
So, this is George Giannakopoulos from Demokritos. So just actually to help the process. So the idea here is to try to write things. For example, it would help a lot if we could initialize a couple of nodes with some examples. So just to understand, we are trying to note down how we as users could utilize, or in which use cases we might utilize high performance computing, for example. This could be one of the things that we fill in. Would it be, I think there's a question. So what is the ideal deliverable after we fill all this in? It's a summary of use cases regarding these settings. Is it some limitations we want to surpass?
Is for make your own proposals of how to use the different technologies or your experience in the different fields of these presented fields.
Excellent. Okay, so it's possible use cases or existing or possible use cases or are ideas of using these different types of computation, right? This is one thing we need to put there.
Yes, different or how do you think that we can use these technologies, or if you use before these technologies, how do you use it, or uh, different proposals for implementing in project?
Yeah, for example, in the expertise presentation, we had two examples. For example, with JRI, we had the chatbot with the natural language processing, and also with the federated learning, that we had to focus in the security on, for example, the risk with the security, and also with the computers that are using to make that models that will be sent to the to the central node. So that's some ideas of what to consider in these topics. For example, in federated learning, take care about the risk with the cybersecurity if you don't use the federated learning, for example, or also have a good computer that could process all the models from the data of this one, and also, for example, with the blockchain that Diego talks about, how the smart contract works with the data and the data lakes, for example. That's a few examples that we need for this activity. So it's just about the experience that everyone have in these topics, and put that experience and the consideration that they think that it useful from each topic of this activity. It's more or less, I don't know if I
Excellent.
explain myself
No, it's
good,
fine.
but
It's fine, Albert.
okay.
It's fine, Albert. Just one last question. And now that I actually have the privilege of having also the microphone. So the idea is that just to also recap, summarize what you all presented. So the idea behind NOUS essentially is somehow to unify all these types of computation, all these settings under a common viewpoint. Am I correct? Under a common way to handle different types of computation, ideally, when the project is over. Am I correct?
Yeah, the idea is obtain all the information about this topic, and then explain them to use it for the NOUS. Okay, so from the NOUS project. So yeah, the idea is using all these notes, just to put them in a white in a white bank, like, yeah.
Yes, to turn them into requirements, let's say, right? To turn them
Yeah,
into
yeah, to take,
specifications. Okay?
yeah,
Just trying to recap to also help people who are beyond the project consortium and might not be sure why we need this. Okay, so the idea is that these nodes will be converted or will help define specifications for the final NOUS project, system platform. Okay.
yeah.
Thank you very
That's
much.
the idea.
Thank you. Thank you.
Thank you.
Hi, Panayotis. Don't worry. I've seen that there are two Christoforos, so don't worry. We know that you have been here. And then when Sofia sends the link for the feedback, just write it as you are the one who came, and that's all.
George, I see your question is yes, not only different types of computation is not only that refers for example, utilization and management the different resources that we have in NOUS in continuous scale. So is referred to computational resource management more than different kind of um, the computation elements that we are be available. So it's referred to the management of the different elements of the project. Okay, Stephen. Oh, and Panayoti, yes, this exercise uh, is not only about the use cases of the project, it's for explore more proposals like we did in the previous workshop, but now with the stakeholders. So it's like for get more information for the project.
Stefanos, could you confirm us that the one that is waiting is George? Because I'm kind of afraid about letting people come. Yeah, okay, it's him.
Okay, 5 minutes left.
Thank you all for participating. Now we are going to send you the form about the feedback for the workshop. So please, if someone of you can send it through the chat, because I'm searching the screen, so I can't. Thank you, Sophia.
Okay, I think that we have 30 minutes left to right now. This is the end of the collaborative activity. I think that until the end of the day, we are gonna have this mural open if anyone have other ideas. So at the end of the day, we are gonna close it. So right now, for the next part, we have the discussion and the question and answer. If anyone have any question, my colleague Alvaro will cover this part. So I don't know if someone have any question about the workshop or if you want to move to the next part. So Alvaro, you have the presentation. Okay,
Yeah,
let me check.
I think he has not access to the microphone or the
Yeah, I think that
I
he
have it
have.
now
Yeah.
for the microphone.
Okay.
I just don't have it for the cam.
Okay.
That's okay. I can respond.
Okay. Let me share the
Just the
screen.
mic.
Okay.
So, are there any further questions, or are we set to go to the community hub explanation? Okay, so it seems that there are no questions. So if you want, we can move ahead to the community hub and give the floor to Sophia to explain about it.
Yes. Thank you, Alvaro. Hello, everyone. I'm Sophia from F6S. Me and my colleague, Elena, we're covering the communication and dissemination activities. And we are also engaged in the community building activities. So the idea that we have in the NOUS project is to create a community around all these activities that you have already heard about, all these initiatives that the NOUS project is going to undertake in the following 36 months, a little bit less already, but how we're going to proceed with the community establishment. We already have created a dedicated link on our website. So Alvaro, could you please stop sharing so I can share my screen? Yes, thanks.
Yes, we can see the feedback.
You see already NOUS website, I hope. I will share with you the link, but we have already created this dedicated link for the community hub on our website. It is very basic. It explains what is the idea, and the idea is very basic: to have already a GDPR compliant database with all interesting stakeholders which are keen to know a little bit more about recent developments, not only within NOUS project, but in the topic that it covers. So feel free to sign up. It is very basic and very easy process. By hitting this Join the Community Hub button, it will open a very simple EU survey that once you fill in, you will become a member of our community. So this everything is GDPR compliant, which was really very important for our team. So your data is secure. Please have a look at it, and this will allow us to stay in touch for the future initiatives and also understand recent developments, not only about our project, but in the domain that it covers. So feel free to do it, and thanks for your participation.